Welcome back, and we're going to take a look at question number 16 from lesson U1A7, applications of vectors. So here we go. We have a 10 Newton force that is acting in the direction of vector with coordinate 1, 1. It moves the object from some point P with coordinates -2, 1 to point Q with coordinates 5, 6. We need to find the work done. The distance is in meters, which means that all these will mean meters. So I kind of prepared the solution in here, or the information, organize the information first. So what we have is a force of 10 newtons that follows the direction of the vector with coordinates 1 and 1. And the displacement caused is from this point to this point. Now I need to find the work done by this force. And I know that work is given as the dot product of force with displacement. So I am thinking that if I knew the coordinates of the force and the coordinates of the displacement, then I can easily find the dot product, and bam, that's the work done. So let's take a look at what we can do about finding the coordinates of the force. Now remember that the force is 10 newtons in magnitude and is following the direction of a vector with coordinates 1 and 1. So here is the vector with coordinates 1, 1, which means that if I were to draw the vector of force, then the vector of force will follow this direction here. Now remember, this angle will be 45 degrees. So if the force equals 10 newtons, it means that the horizontal and the vertical components formed by dropping a perpendicular here would be equal. So I'm going to call this one A and this one also A because they're equal. And I will try to find out what each measurement is so that I can identify in this way the coordinates of F. Obviously, we can also use the SOHCAHTOA, or the component form of each vector. So that would be the same thing. We haven't gone through the component form in this unit, so I'm going to use a simple SOHCAHTOA, or the simple right angle triangle isosceles right angle triangle formula, or Pythagorean theorem. So according to Pythagorean theorem, then we'll have here a squared plus a squared equals 10 squared. So in other words, we have 2a squared equal to 100, which will make a squared equal to 50. So that will make the value of a equal to square root of 50, which is basically square root of 25 times square root of 2, or 5 root 2. So we're going to say that the force F with a magnitude of 10 newtons has the coordinates 5 root 2 and 5 root 2. So far I'm happy that I found the coordinates of the force. So what we have in here is 5 root 2, 5 root 2. That is dot producting the displacement. Now for displacement, obviously we have to use the information given for the coordinates of points P and Q. It is very important to remind ourselves the fact that the object is moving from point P towards point Q, which means that Q will be the head of the vector and P will be the tail, because we're starting at P and ending at Q. So if you were to actually draw or plot the points, we don't have to, but if we were to plot the points, let's do this just for the fun of it. So -2, 1, that will be the point P, and point Q will be at 5 and 6. So 1, 2, 3, 4, 5. And then we go up here, 1, 2, 3, 4, 5, 6. So this will be the displacement vector. And obviously, if you bring the displacement vector in the position vector form, or at the position vector, then you will see that the coordinates of the position vector for displacement will be at 1, 2, 3, 4, 5, 6, 7 for x, and 1, 2, 3, 4, 5 for y. So 7 and 5. Now, obviously, we don't have to do this graphically. We can very easily find vector PQ, because we know that displacement is represented by vector PQ. And for vector PQ, we always go coordinate x from Q, which is 5, subtract the coordinate x from p, which is -2. And for the y coordinates, we go 6 minus 1. So y at q minus y at p. And you can tell and you can see how we get the coordinates that we obtained from the graph. It's kind of nice to see it in both ways because it is more convincing. So as you can see now, we are almost ready to find the work done caused by this force. And we are ready to dot product these two vectors. So remember that we have to multiply x's together and y's together. So 5 root 2 times 7 plus 5 root 2 times 5. So here we are. And 5 root 2 times 7, that would be 35 root 2. And 5 root 2 times 5 is 25 root 2. And 35 plus 25, that would be 60 root 2. So the work done will be 60 root 2 Newton meters or 60 root 2 joules. And this is the solution to question number 16. I hope this made sense, and you can try question number 17. It's very similar, but here we are in 3D. Thank you for watching again, and I hope you found this helpful. Bye for now.